Welcome to Mickey Study Circle channel. In this video, we shall see how to do the computer drafting of the development of the lateral surfaces of the solids using the Solid Edge software. In this problem statement, we have a pentagonal prism of 20 mm sides of base and 50 mm height standing vertically with one of its rectangular faces being parallel to the vertical plane and is nearer to the observer. And we need to produce a one-piece development with the inclined plane which is 30 degrees towards the axis and is passing through the right extreme corner of the top face of the prism. So with this condition, let us see how to draft the solution for this problem. So first let us begin by drawing the XY line of thickness 0.18 mm. Next we shall consider constructing the top view of the pentagon. So first let us consider constructing the pentagon as per the given dimension. So that is 20, 72, 20, 72 into 2 followed by 20 mm, 72 into 3 and then 20 and minus 72. So this is the pentagon. But however, as per the given condition, one of its rectangular faces must be parallel to the eh, vertical plane. So for that, let us consider selecting this pentagon and then rotating this in such a way that one of its faces become parallel to the XY line. So as you can see here, this face is parallel to the vertical plane as per the given condition. So now let us consider constructing the front view of this pentagonal prism by drawing the projection lines from each of the corners. So the axis will also pass through this line itself. So we'll consider constructing the axis of the prism which is equal to 50 mm and then construct the other rectangular faces. So now we shall do the annotation. So go for the text and annotate the plane first. So this is X and Y and also the reference planes as VP and HP. So let us construct the resting edge as E and D. So let us consider nomenclating it from this point. So this is the corner A and the corner A1 of the bottom face. Similarly, this is corner B and B1 from the bottom face. Similarly, corner C, corner C1 followed by D and D1, while this is the corner E and E1. Now let us annotate the front view. So this is the rectangular edge C1 dash, C dash, followed by D1 dash and D dash, and this is the corner B1 dash, B dash. So the axis will be behind this, so we are not representing that in the sketch. And this is the corner E1 dash, while this is the corner E dash, followed by the extreme left corner, that is A1 dash and A dash. So this completes the annotation of the pentagonal prism. So let us show the axis height which is equal to 50 mm and then one of the sides which measures 20 mm. So now as per the problem statement, we need to consider constructing the cutting plane. So the cutting plane is passing through the right extreme corner of the top face of the prism, which is from the corner C dash and is inclined at an angle of 30 degrees. So for that, let us try to draw a line from the extreme right corner from the top face, but the angle must be equal to 30 degrees. So we'll just measure the angle and check. So this is 50. We'll change this to 30. In the question, it tells that the inclined face of the truncated prism is 30 degrees towards the axis. So from here, what we can do is we can just reconsider constructing the cutting plane. So we'll simply randomly draw a line first. So in order for the truncated prism to be 30 degrees, select the axis line on this cutting plane and enter the angle as 30. And this is how the prism will be cut. So use the trim option. So trim this cutting plane which is coming beneath the XY line. And then let us change this line to a cutting plane. So now you can just see that this portion of the prism is retained and this portion of the prism is chopped off, and we need to show the development of this particular portion of the prism. So the prism is intersected on its edges, that is A and E. So from here, let me draw a vertical projection line to intersect AB and as well as AE. So these are the points that has to be considered on the edge lines, whereas all the other points will lie along the rectangular faces. So now we'll go for the annotation part. So we'll tell that the prism is intersected at the point 1. So we'll consider the starting point as 1 dash, and that point could be on AB. So this is 1 in the top view. And next, the point on B1 dash and B is 2 dash. So this is 2 dash, while on C1 dash and C dash it is exactly on the corner C, so it is 3 dash. Followed by D1 dash and D dash. This is the point 4 dash. Next, we have got this edge, that is E1 dash and E dash, which is 5 dash. So these are the 5 points, and also the point on A and E. So this point is 6, and here it is 6 dash. So these are the salient points that we get, which is the interaction of this cutting plane along the rectangular edges. So now let us darken the edges that is visible to the observer. So go to the line option, select a line of thickness 0.50. So we'll start from here, complete the base of the prism and extend this till the topmost right corner, and then from the point of intersection of the cutting plane towards the base of the prism, all the edges shall be marked as visible. So these are the developed surfaces that has to be shown. So now we shall highlight the visible lines on the top view. So the prism is cut like this. So this is the point 6, 1, 2, 3, 4, 5, 6, and 1. So we'll just annotate the points. So the point 2 is on BB1, and then the point 3 is on CC1, and the point D is on point 4 is on DD1. And this is the point 5, which is on EE1. So these are the points. So now we need to understand the distance of the point 1 on AB. So what we can do is go for the distance between. You can either measure the distance from B to 1 or from A to 1. So let me consider A to 1, which is equal to 4.32. And similarly on this edge, that is A and E, the distance between A to 6 or E to 6. So anything can be considered. So let me consider the distance of A to 6, which is equal to 10.79. So now we will cut open the prism. So in order to represent the cut section of the prism, let us take the reference of the xy line and draw a line of total length, which is equal to 20 into 5. So we are going to divide this into 5 equal parts. So the rectangle shall measure 20 cross 50. 20, next again 20, 20. So we have done the 5 equal divisions of the rectangle, which is representing the cut section of the pentagonal prism. So since it is a pentagonal prism, each rectangular face will be having a dimension of 20 cross 50. So you can just go to the smart dimension tool, show the height, and then the total length, which is equal to 100, and then the distance between any two parallel edges, which is equal to 20. So this completes the first part of showing the development. So now we will annotate the rectangular edge lines. So this is A1 and this is A, followed by B1 and B, C1 and C. This is D1 and D, while this is E1 and E, and then back to the edge which closes the prism, that is A1 and A. So now we shall identify the points. So first, in order to locate the point 1, which is between A1 and B1, what we can do is we can just draw a line of length A to 1, which is equal to 4.32. So A to 1 will be having a length of 4.32, and the line will be exactly on this edge line. So this is the point 1. So next we have got the point 2, which is on BB1. So for that we shall draw a parallel line to intersect BB1. Next, 3 is on the corner C, 4 is on DD1, 5 is on this E1E, and next again we need to mark the point 6, that is 10.79. So that is from A to E. So A to E on this side 10.79. So these are the points. So now we need to show the development. So select a line of thickness 0.50. So we shall start from this point, that is 1, while 2 is here, marked by the point 3, which is on the corner C, followed by the point 4, which is on DD1, and then 5, which is on EE1, followed by 1, which is on A1E1. So close this, which is the base of the prism, and highlight all the other edges on the rectangular faces. So these are all the edges that has to be shown. So this is the development. So we can just indicate that this is the development. And we shall annotate the points. So this is point 1, 2, 3 is on the corner C itself, and then 4 on DD1, and then this is 5 on EE1, and this is the point 6 on the edge A1 E1. So these are the salient points. So you can just show this distance on the development also. So go to the distance option. So between this, which is equal to 4.32, and similarly A1 to E1, which is equal to 10.79. So with this, we complete the development for the given problem statement. Thank you all for watching.